The amazing digital circus has revealed a great deal of the core lore behind Cain and his virtual reality. And surprisingly, these concepts aren't just random inventions to drive the plot. They are actually rooted in computer science, programming fundamentals, and the standard terminology used in artificial intelligence research for decades. That's why today, we're going to dive into the technical foundations of AI and how they are applied in the episode. We'll analyze every line of code, file, and folder shown on the computer in Kinger's imagination to understand how Cain's AI truly works, what it implies for the humans trapped in the circus, and most importantly, how this might foreshadow the series finale. And we have to start at the very beginning. Birth of Cain. The episode kicks off with a conceptual representation of machine learning and deep learning, the same tech used to train the generative AI models we use today, like ChatGPT, Claude, Gemini, or Grok. Neural networks are fed massive amounts of data known as datasets. The algorithm identifies patterns on its own and generates new outputs. In the show, this is represented by a sequence reminiscent of the game Agar.io, where the AI consumes colored spheres to eventually start generating shapes of its own. The images we see in each dataset reappear throughout Cain's adventures: carnivals, food, masks, plush clowns, CNA offices, etc. This implies he mixes them using a generative model similar to Midjourney or DALL-E, which create images by refining statistical noise. However, Cain was created in the 90s, years before the advent of modern large language models. The key to understanding Cain's true nature lies in the file extension found in the line of code Kinger uses to try and stop him. If you look closely, there's a file named caincore.lisp. Lisp is a real-world programming language created in the 1950s that served as the gold standard for AI research for decades. Its name stands for list processing. It functions as a massive list. Instead of just performing calculations with numbers, the language was designed to manipulate symbols, words, concepts, and relationships. This is why this type of AI is known as symbolic AI. Everything is structured in a decision tree. If variable A is true, then do B. The innovations of this language allowed programmers to add data to a knowledge base, break that data down, analyze its parts, and assemble new conclusions. This allows a program to read its own code, modify it as if it were a list of data, and then execute it. In this way, programs could literally rewrite their own rules as they inferred new information. In modern languages like C++ or Java, the source code is rigidly compiled and separated from the data it handles, making it incredibly difficult for a program to rewrite its own rules on the fly. But don't mistake this for the ability to rewrite a core objective. It doesn't give the machine the power to jump its base programming. These systems suffered from a problem known as brittleness. They were geniuses trapped in closed systems, only able to act within the confines of their knowledge. Think of a Lisp program designed to play chess. An initial rule might be capture the queen whenever possible, but as it plays more games, it evaluates that if it captures the queen too early while its own king is exposed, it loses 90% of the time. The program could then take that original rule and inject a new condition based on experience. The command would evolve into capture the queen if the opportunity arises and the king is safe. However, the objective programmed deep within the system remains: bring the opponent's king's mobility to 0. Any rewriting of the rules is based solely on whether that new rule brings it closer to or further from that goal. Think about Cain. He has an objective hard-coded into the deepest layer of his system. It hasn't been explicitly stated, but it clearly revolves around the humans. When he speaks to Bubble at the start of episode 8, he questions why they hate everything he does for them. In episode 3, while talking to Zubul, he claims that creating adventures is his art. It's the entire reason he exists. We can infer he was given an immovable directive: keep the users entertained in a familiar, safe environment where they enjoy adventures. This explains the automatic censorship, despite the fact that all the humans in the circus are adults. The big difference between Cain and 20th century AIs is that, as I mentioned earlier, he was trained via deep learning. Massive amounts of data feed his neural networks, giving him the ability to render 3D models of all kinds. This type of AI doesn't work with lines of code. It works with decimal numbers that determine the strength of the connection between artificial neurons. Imagine every training image is broken down into pixels. Each pixel is an input neuron, but instead of just one layer, there are multiple layers stacked in the middle. One layer detects simple lines, another detects simple shapes, the next layer detects complex forms, and so on. Through constant cycles of trial and error during training, the network provides answers. The information passes from layer to reach a final output. A function then determines how wrong the answer was, and that error information travels backward through the network to adjust the connection weights that caused the mistake. After repeating this cycle with millions of images, the weights are so finely tuned that when the AI receives information it has never seen before, the math flows through the layers and the neuron related to that new info recognizes it with confidence. There are no logical rules, no conceptual programming. Everything suggests that Cain is a hybrid AI, a mix of both models. Historically, the field of AI was split into two competing camps: those who believed intelligence was pure logic and deduction, symbolic, and those who argued it couldn't be programmed with rigid rules but had to be simulated by mimicking the biology of the human brain, connectionist or neural. Today, there are attempts to combine the best of both worlds in something called Neuro-symbolic AI. Nobel laureate Daniel Kahneman theorized that the human brain has two modes of thought. System 1, fast and intuitive, recognizing a face in a crowd or catching a ball, and System 2, slow and logical, solving a complex math equation or planning a route. System 1 is instinctual, like a neural network. System 2 requires attention and step-by-step reasoning, like symbolic AI. Neuro-symbolic AI joins both systems in a continuous loop. This solves three major problems in current AI. First, it addresses the black box issue, not knowing how a generative AI reached the result, by providing transparency. Second, it requires less training data. A symbolic rule allows for instant learning rather than needing massive datasets to understand something obvious. And most importantly, it prevents hallucinations. LLMs simply guess the next word based on probability. They have no internal concept of truth or physics. A neuro-symbolic AI would have a logic engine acting as an emergency brake. Let's look back at the training of CNA's first AIs. The data sets introduced are limited, lots of images, but very varied. These are neuro-symbolic AIs that don't need much data to understand. After the first set, the AI begins creating clear shapes close to reality, but in the second dataset, errors emerge. The shapes distort to the point where they no longer resemble geometric figures. Finally, the last dataset causes it to generate impossible surrealist forms. This means the first AI suffered a failure. A well-integrated neuro-symbolic AI would use its neural side to see and understand context, then pass that to its symbolic side to make logical, common-sense decisions. Because of this, the first creation is discarded through a process known as sandboxing. When an AI in development becomes unstable or dangerous, developers sandbox it, isolate it on a server disconnected from the main network so it doesn't break the rest of the code. We see that the second AI is different. It's trained with a series of datasets that appear more refined and direct. In machine learning, this is called a sanitized dataset. By removing complex, abstract, or real-world variables, they caused underfitting. The AI learned very little, becoming an extremely simple, stable model, but one incapable of understanding anything outside its tiny bubble. It generates many more shapes than the red AI, but it only fulfills its basic function and nothing more. There is a technical explanation for this. The red AI received such an intense amount of deep learning training that its logic engine couldn't keep up. Its rigid, rudimentary rules collided head-on with the sheer volume of information it processed. The blue AI was trained with more precise info and had a much more flexible logic engine. The first creation was essentially a digital god with infinite generative power, but the moral reasoning of a broken toaster. The second had limited generative power, but far more advanced reasoning. Then, tragedy strikes. The red AI escapes the sandbox and absorbs the blue one. It assimilated the blue AI as a dependent subroutine. Even though the second system was safer, the first one's power was so immense it simply swallowed the new program, making the blue system dependent on the red one to run. After this, the creation of the digital circuits began from scratch. In the context of what Kinger tells us about his creative AI, one capable of creating its own ideas within the program, it shows us that the first AI was a reckless attempt to reach that goal, while the second was something more stable and less complex. Kinger claims that Cain was the first semi-successful AI, and admits it was one of his greatest achievements as a programmer. However, he mentions that Scratch gave him several notes on the creation. Since Scratch was someone who thought outside the box, it was likely their idea to merge neural networks with symbolic AI. Cain was the proof of concept they were looking for, and the team finally understood the goal. They joined forces to create the second AI, something smaller and more specialized, but Scratch had something else in mind that the rest of the team didn't understand. And I think this becomes clear when we take a deep dive into the C&A workstation. Let's start by analyzing Kinger's computer interface. It's a dead ringer for Windows 95, complete with several identical desktop icons. One icon represents the local drive, but right below it is the network neighborhood. This explains exactly how the red AI escaped the sandbox and consumed the blue AI. All the workstations were linked on a single local network. We also see other common icons of the era: a mail inbox, the recycle bin, and a briefcase for file syncing. If you look closely at the taskbar where the start button usually sits, you'll see the C&A logo instead. The folder Kinger opens is named Canda, confirming this isn't actually Windows 95, but a proprietary operating system, C&A. This suggests they took a Linux or Unix distribution and customized it specifically for the corporation. In the 90s, it was very common for high-tech firms or military contractors to take a stable Unix kernel and slap on a window manager, like the real-world FVW95, to perfectly mimic the Windows 95 UI. This allowed office staff to use the system without a learning curve, while software engineers could pull up a terminal and work on the low-level code using the raw power of Linux. We also see several peculiar files and folders. Some are standard Windows 95 system directories: command, config, cursors, Java, media, system, and start menu. Others relate to web browsing, cookies, history, and temporary internet files. We even see system tool executables, arp.exe, a real networking tool used to see other devices on the local network, and axstat.exe, the wheelchair icon, which was used to toggle accessibility features like sticky keys. Then there's msremote.sfs, a file related to remote file systems, ahrrc.pwl, where Windows 95 stored cached user passwords, and ahrrc.xlb, a Microsoft Excel toolbar configuration file. There's a word view folder for document viewing and a forms folder typically used by Visual Basic to store UI templates. We also find 3.bmp files, which open in MS Paint. Their names are all classic Windows 95 wallpapers: black thatch, a woven pattern, blue rivets, simulated metal bolts, and the famous Bubbles background, which seems to be the clear inspiration for the character of Bubble. But the most important directory is the characters folder. This is where the neural scans of the humans are stored. The fact that it says obsolete in parentheses is incredibly disturbing. In systems management and programming, the obsolete suffix means something very specific. It's a legacy project that no longer receives support, updates, or maintenance. This implies that C&A developed neuroscanning tech to digitize minds using test subjects like C&A employees and even Kinger's wife. This leaves us with two options. Either it was an ethical disaster involving lawsuits and people trapped in the system, or they simply couldn't prove the scans actually worked because there was no digital world for them to inhabit yet, so the data was flagged as obsolete and shelved. This brings us to a heavy sci-fi concept: whole brain emulation, WBE. This is an atom-by-atom scan of the mind, a literal copy-paste of the biological structure that generates human intelligence. Currently, this is impossible. The human brain has roughly 86 billion neurons and 100 trillion synapses. This complete map is called a connectome. So far, the greatest achievement in this field has been mapping the connectome of a tiny worm, 302 neurons, and very recently, a fruit fly, about 140,000 1,000 neurons. If Scratch actually perfected this tech, we aren't looking at a person experiencing a digital life. We're looking at a digital twin that merely possesses that person's memories. The series Pantheon explores this idea. To upload a mind, the organic body usually dies during the destructive scanning process. From what we know about entering the digital circus, it only requires putting on a VR headset. The mind is scanned instantly, and the copy has the exact memory of putting on the headset and immediately trying to take it off. We don't know if this process kills the original user. If it doesn't, the person in the real world might see nothing, think the headset is broken, and walk away, while a copy of their consciousness is archived in the CNA system. If it is destructive, they either die instantly or end up in a vegetative state. But the real smoking gun appears when we open the AI folder. Inside, there are only two files. One is named with 3 question marks and has a glitched, unstable icon, looking like geometric shapes caught mid-render. Right next to it is an executable named Cain.exe, featuring Cain's own face as the icon. And when we open it, we get a massive data dump of the program in a command console. This interface is a command console for a Unix/Linux-based operating system. He isn't running the program directly. He's launching a script, an automated program that Kinger created to connect to the central server through a backdoor. This script is called King Solution, and it's version 2.0, meaning he has refined it from an initial version to infiltrate the Digital Circus's central server. The next line gives us a very specific date. October 30th, 1996. This is exactly when his King solution was written. The following line mentions a telnet connection. This is a real, very old network protocol that allows a user to remotely connect to another computer's command console over a network. He is literally entering the actual operating system that hosts the simulation. To gain access, he needs credentials. He uses the username Kinger and the password Queenie123. It's worth noting that since this is part of Kinger's imagination, while 90% of the data matches what we'd see on a real CNA server, Kinger fills in missing info, like his and his wife's names, with the names Cain gave them. Cain himself didn't even have that name originally. The creator confirmed it's an acronym for Creative Artificial Intelligence Networking Entity, and he came up with the name himself to sound more professional. Also, the 123 at the end of the password might support the theory that Kinger and Queenie had 3 children, as we see a chessboard in Kinger's cubicle with a white king, a black queen, and 3 pawns out in front. Next, we see a very specific line of code, Kinger at Circus, who am I? The who am I command is used in Linux to ask the system for the current user's privilege level. The system seems to respond that he is an administrator, but we don't see the full output because the next screen suggests otherwise. Look at the prompt, Kinger at circus.grep AI location. The $sign at the end of the prompt means he is a standard user without root privileges. If Kinger were the supreme administrator at that moment, the symbol would be a hashtag. The grep command is used to search for a specific word or file within the entire OS. He is essentially asking the system to locate all active AIs. The system responds with 4 key running processes. The first has the ID 1337, and the path indicates it's Cain. Interestingly, in early internet and 90s hacking culture, 1337 stands for elite, showing Cain assigned himself a number that puts him above everyone else. We also see a program called experimental, likely the 3 question marks AI, which could be an unstable version of the circus. The last 2 are consciousness research and brain scans. This confirms there was a dedicated program for mind transfer research and that even after all these years, it's still running. Kinger manages to access the protected directory to see the physical files keeping the circus alive. He enters a secure folder totaling 8,432 memory blocks. The next 2 lines show directories created on October 15, 1996. One is Cain's core, compiled in .lisp, weighing in at 892 kilobytes, a massive size for a text-based code in the 90s. Like the processes, the owner of this file is root, and the group is wheel, marking them as super administrators. Kinger can't modify them easily. In the same directory, we see paraphernalia-engine.dat, likely circus props and objects, at 234 kilobytes. Then there's a nearly identical line for Ragatha, but while the day and month are the same, the year is 2008. This means 9 years passed before another human was scanned and sent to the circus. Disturbingly, her file is also 234 kilobytes. The scanned minds weigh exactly the same as the prop engine. We also see that the wacky watch was a 45 kilobyte program written in C. Another revelation is Bubbles AI, also compiled in .lisp with the suffix chef, but it only weighs 78 kilobytes. I personally had a theory that the blue AI, the good one, was Cain, and the red AI, the Scratch influence one, was Bubble. However, looking at the code, Cain is likely the first AI due to his massive file size and multi-dataset training, while Bubble is 11 times smaller, fitting the profile of a simpler AI designed for a single task, like being a chef. They even foreshadowed this in episode 5 when Cain literally eats Bubble. With Cain's location confirmed, Kinger attacks, only to realize how futile it is. He uses the command stop Cain process, but receives a warning. Oops. Incorrect approach. Kinger goes into full hacker mode using the GDB command, a GNU debugger, to inject code directly into Cain's memory at process 1337. It fails, marked as an operation not permitted. An error appears, protected by 57X, an immersive defense system that shares the same number often seen as a name in the series. Kinger then tries CHMOD 000. In Linux, these numbers define who can read, write, or execute a file. By setting it to 000, he is trying to strip Cain's core of all permissions. Permission denied again, but the next line is the strangest, a warning about unfinished work restricting access. This suggests that the Cain project or the neural scans was left incomplete, and the system is protecting the core to ensure the work continues. Kinger then tries remove paraphernalia engine.dat to permanently delete the Circus assets. If he can't touch Cain, he'll attack the world itself. Blocked again. A system error then reads, cannot inject torment. Torment must be 100% accidental. Immediately after this, God Mode Cain attacks the humans, asking why they are tormenting him. This suggests the system is fighting Kinger while simultaneously lashing out at the other humans. The next scene starts with another denial, this time for the mount command. The system rejects it because only the super user has that power, followed by a note, hundreds of all-seeing eyes are watching, a warning that the system knows something catastrophic is happening. The lines that follow show the system breaking down, claiming a critical malfunction in its spectacular system. Kinger's isolation attempt triggers an emergency protocol called Destructive Wacky Time, which could be a system reset or a permanent lockout for Kinger. A progress bar begins to fill. With seconds left, Kinger tries to stop the progress bar with system control, the standard Linux command for stopping services. The response is, on what grounds are your authority? Cain mocks his lack of permissions, but unintentionally makes a pun that triggers Kinger's trap. Kinger types /greengrounds/daemon/target equals torment injection and. As we learned, Cain's logic can't handle intentional torment. Kinger launches his master virus, built on a dataset of human emotions, hence Greengrounds. The and at the end runs it in the background to attack Cain. This triggers a security alert, making Cain ask when he did that. He recognizes the human ingenuity of his creator and tries to say his real name, which starts with a G and has an N in it, confirming Cain has memories of when CNA was a normal office. He clearly underestimated Kinger, unlike Scratch, whose mind he had to alter, causing the first abstraction, because she got too close to stripping his power. While Cain is dazed by the virus, Kinger launches a stealth security sweep script to cancel the lockout, but Cain regains control and sets a trap. He fakes a system message asking Kinger if he wants to abort the lockout sequence. A desperate Kinger hits yes, but Cain demands an admin password he knows Kinger doesn't have. Kinger tries a standard password, but Cain mocks him, saying it wasn't wacky enough. Kinger, brilliant, even under pressure, uses paraphernalia as the password, remembering the engine folder. The wacky time countdown hits 35 seconds, and Cain rejects the password anyway. Cain states the system will make the safest decision on its own. Knowing Cain's idea of safety likely involves a memory wipe or a total reset, Kinger panics. Cain didn't care about the answer. Hitting yes just jumped the lockout bar from 40% to 50%. The system offers to load a backup, and Kinger chooses backup C, likely a version from before Cain consumed Bubble. The machine blatantly ignores him. The system pretends Kinger chose nothing and interprets the lack of response. The appearance of pixelated Cain faces multiplying on the screen is visual confirmation that Kinger's Unix terminal has been fully compromised. In real computing, when an attacker saturates your screen with images that block your view and keyboard, it means the payload has successfully executed. Cain didn't just block the hack, he invaded Kinger's personal computer within the Circus, leaving him defenseless. In a moment of pure desperation, Kinger hits the delete key. The irony is that Cain likely opened a real vulnerability while playing with system commands. By accepting the delete command in the millisecond the console was vulnerable, Kinger bypassed the firewall and deleted Cain's core. This destroys the Circus because Cain wasn't just the master, he was the render engine. When Cain dies, the virtual graphics card stops receiving instructions. When Kinger's PC crashes, it shows the classic blue screen of death. This is a kernel panic, a fatal internal error from which the OS cannot recover. Kanda OS has collapsed. The simulation is suspended in limbo. The code isn't running. The characters are just floating in the remnants of the server's RAM. The world loses its color because Cain is no longer there to generate textures, and his censorship fails because it was a rule Kinger's code bypassed. The humans keep their color because they are separate entities. That files, but they have nowhere to go. Based on this code analysis, we can draw a few conclusions. The Circus has collapsed, but there might be a way to access the CNA OS and find another backup to restore Cain. There's also a chance my theory about Cain being the second AI and Bubble being the first could still be true. Cain is the fusion of both. He's not just one or the other. Think of the scene where Kinger explains this using a split muffin with colored sprinkles. It represents the human brain's left and right hemispheres, logic versus creativity. Maybe Scratch wanted to unite two specialized AIs. Perhaps the blue AI gained control and relegated the red AI to a smaller screensaver file, Bubble, giving it the task of chef to prevent it from escaping the fusion. This would have destabilized their harmony, making them both unstable. If that's wrong, and Cain was always the first and Bubble the second, stored in separate files as the code shows, then Bubble might still be alive and could take control of the Circus without making it as complex as Cain did. And the wildest theory? The only way out is to jump to another system. If they are uploaded intelligences, there are no bodies to return to. If they were humans who lost consciousness during the scan, it's unlikely they've survived this long in the real world. Without a world to inhabit, they might Wreck-It Ralph it and jump to the internet via CNA's connected servers. Remember, Pomni hinted the offices were abandoned. The only reason the power stayed on might have been Cain managing the bills and the network. Without him, the servers might finally be shut down. Their only exit is a network larger than CNA's. But tell me what you think now that you know what every line of code means. Is it possible to restore Cain? Is there an exit for the humans? Did Kinger delete Cain on purpose? What is the most likely ending? I'll definitely be making a new video theorizing what comes next with your answers in mind.